All right, T minus. Oh, it just popped away on my screen.
Yeah, I just clicked it. So,
we're recording.
Brian, why don't you turn your video off and just be there in the background in case we need something?
Okay.
T minus 30 seconds, boys.
All right, boys. Good luck.
Thanks.
74 people in the waiting room.
Great.
All right, boys. 5 seconds. Good luck, everybody.
Peace out.
All right. Welcome, everybody. Thanks for joining us this morning. And we'll just give it a minute to make sure everybody gets in from the waiting room.
What's up, Living Soil nerds?
What's up, Brian?
All right. Well, let's get started. Thanks for joining us this morning, everyone. So you are joining the first session of the conference. So I want to just start out, introduce myself, introduce our speaker, tell you guys a little bit about how this event came to be. So I'm Daniel Enking. I'm the CEO of Everflux Technologies. And so this event kind of came out of a previous conference, the Science of Regenerative Organic Cannabis Cultivation Conference. I think I got that right. It's always been a mouthful. But that was, a lot of people knew it just as the Regen Cannabis Conference. So that was put on by Leighton-Morrison. He was one of the founders of that conference. And when COVID hit back in the spring, unfortunately, that had to get canceled. So, several months later, Leighton, wanted to keep that conference going. And he met Brian Waxman, who works for us at Everflux Technologies. And the two of them got together and said, hey, why can't we put this on as a virtual conference? So Everflux Technologies joined up and partnered with Leighton. We created this organization we call Everflux University so that we could do educational events about growing with living soil, about growing regeneratively. And so that's how this conference came to be, this academy. So thanks for joining, everybody. And just want to give you a few announcements before I pass this off to Leighton here. So we've got a chat function here, and we've got a Q&A function. You're free to, post whatever you want in the chat. If you have questions for the speaker, for Leighton, please put those in the Q&A box, and you can also upvote questions there too if you like somebody else's question and you just want to get that question answered. I'll be keeping an eye on those while Leighton's giving his presentation, and then after the presentation, we will get to Q&A. Also, one more announcement for everyone. In case you didn't get the email we sent out, we had a little bit of a switch in the program. So Elaine Ingham will actually be going second today, and her session starts at 11:30 Pacific time. And then Chip Osborne will be going in the afternoon, starting at 2:30 Pacific time. So just had to switch those two around a little bit last minute. So just make sure you're going into the right session later. And with that, I will pass it off to Leighton-Morrison. He's really the brainchild behind this whole event and everything. So we're really excited to hear his talk this morning. All right.
Thank you, Daniel.
Yeah.
All right, Daniel, where are my slides?
You're just going to hover over it, buddy. Just hover your mouse over it. There you go.
Beautiful. All right, gentlemen and ladies, I'm going to try to unteach what you know about soil and give you a different perspective. I kind of like to take you out of your comfort zone, take you out of your body and mind for a minute here, and try to get you to look at things a little differently. What is psychical soil? All right. Yes, there actually is a word psychical, and it's psychic and physical. And in many ways, I truly believe that soil is something that's beyond our comprehension, supernatural, paranormal, paramagnetic, spiritual, extrasensory, subliminal, subconscious, clairvoyant. And in order to take this to another level, I want to talk about the definition of life. I struggle a lot with this because, here we are in the 2020, and we say a sperm is alive and an egg is not. I think that our perspective of life and that definition needs to be revisited. We say viruses are not alive. Well, viruses have been around since the beginning, and they have steered evolution. When something gets out of whack, the virus sets in, culls the herd to some degree, and then allows a rebirth to come out of the chaos. And so, again, I think that in this day and age, we should be looking at things, have a better perspective on what we define as life and what we define as not alive. One of the other pieces of the puzzle that I really want to talk about is the fourth phase of water. For you out there, please just write that down in between sessions, or tonight or tomorrow, whenever. Google it. There are people out there that are trying to debunk this understanding or concept. So I don't want you to focus on that. I want you to focus on what was written and what has been talked about. It's kind of like, when you take your shoes off and you walk in the sand, there's a connection there. The sand just makes you feel good. Same as rolling around in the grass, in the sunshine. There's something going on there. There's a connection to the earth through the moisture, through the water, whether it be a mist or a vapor. There's a connection there. And in the fourth phase of water, they touch on structured water, which I'm not a big fan of that term. I like to think of it more as understanding the water's ability to transfer information, millivolts, EC, electrical conductivity. I'm actually reading a paper right now by a gentleman. His first name slips me, but his last name is Bally, and he's actually taken it to a whole nother level. I'm like, without a way to define it other than it's the fifth level. And so some of his work is kind of showing us that inside a bacteria, which is 1 micron, so you can't see it unless you have a microscope, so it's very small, there are 3.3 billion water molecules in that single cell. And the way those water molecules line up allows for information to be transferred from one part of the cell to the other. And so that's kind of the direction that I want you to start thinking about water as well, and life. I think that these definitions really need to be explored deeper. And hopefully in the next few years, we really start to pay attention to some of this stuff. So moving on, this has always been one of the funnest questions I ask when I'm sitting around with a bunch of nerds or people that are way smarter than me. And that is, where does the soil stop and the plant begin? And again, this is a conversation that's beyond what most people stop to ponder about, but it's an important question. And, you can grow hydroponically, which is in water, but we just talked about water and its properties. So I don't think you can sit there and say that just because you're growing in water, you're not connected to the soil or what I want to call the aquatic food web, which is very similar to the soil food web. And we'll get into that in more detail as we go forward. But just stop for a second and ponder that question. Where does one stop and the other begin? And it's a deep question, and I've stumped a lot of really brilliant minds with that question, and made them just sit back and go, well, wait a minute, I never thought of that. And so I think it's an important question to ask yourself, especially today as we move through this. Again, I'm trying to get you to think outside the box of what you know, and in hopes that I open your mind to some things that perhaps you hadn't quite thought about yet. So what are the properties of soil? Soil science says, and this is dogma, that soil is defined by the particulate size and not the properties of the particulate. And to me, that just makes no sense. Sand, silt, and clay all have different properties. If you've ever done a home textural test where you've taken a handful of your soil and you put it in a mason jar, added a little bit of water and shook it up, you will see it settles out differently. The sand settles first, clay second, the silt second, and the clay last. And then, of course, what's floating is your organic matter. So right away, the specific gravity of sand, silt, and clay and organic matter are all different. And we're going to get into specifics on what the properties of each one of these are. And that will hopefully get you to start to understand that they're critical components in growing plants of any kind. So another piece of the puzzle that is not discussed or talked about often is soil is only 50% physical matter. The other 50% is air and water. And that's where you get anaerobic and aerobic conditions. So in the silt on the bottom of a creek or a riverbed is anaerobic. You step in it and you pull your foot out and you're covered with mud that smells pretty nasty. So that's anaerobic. And on the other end of the chart, you have a desert where you have very little moisture. Now, there is vapor trapped down lower into the sand, but it's very aerobic. So it's almost oxidative. It's almost like very difficult for that moisture to hang around and be supportive of plants. Now, there are some plants that live in deserts, but they're pretty scattered and not a lot of diversity. So remember, soil is only 50% the physical matter, and the other 50%, the water and the air or gas exchange, are very, very important to support healthy plant life. All right, so what is sand? There's really kind of three components to sand. It could either be silica or quartz, and I want you to think about that and look at that molecule. 1 part silica, 2 parts oxygen. So if you have a bacteria in a soil system that is mining silica for the plant, remember the plant sends down exudates to target specific bacteria to mine specific things to then make it available for the plant. So as that bacterium pulls up the silica to make it available for the plant, it's releasing oxygen. And so this is, another key piece to understanding how these components of soil are so important in providing the diversity that you want in your soil system. I've had people say, oh, we only need NPK. Well, we've learned that lesson. There's way more nutrients than you need just NPK. And then I've heard people say, oh, well, there's 17 nutrients. Yeah, I think that's narrow-minded. I think that when you start to think about the biological constituent that goes on, in many ways, a specific bacteria's main purpose could be just to grow and die off and provide a substrate or a food source for another bacteria. So I believe every part of the periodic table is important for advanced life to happen. And at some point in some time, all of these minerals were being consumed or are continually being consumed just to support the next level of advanced life or evolution. Another part of sand can be calcium carbonate, and we all know how valuable calcium is in our soil system for our plant health. Yes, it's basically fossilized corals and shells. Now, I've got people saying, oh, well, we can't get calcium carbonate sand in the Midwest. Well, that's not true. At some point in time, over the last billions of years, everything has been underwater. Everything has had an ocean, a sea, a shallow amount of water over the top of it that allowed some type of crustacean to exist. So all it takes is erosion and water movement, and in some cases just wind to expose that kind of material. And, I think that another great misnomer is the understanding that the vast majority of soil on this planet, I believe it's about 80%, was moved through transportation or was formed through transportation. So the wind, the water, the sun heating it up, and the water freezing and breaking it apart. So all these things are part of the process of forming soil, and soil often took thousands, if not millions of years to form in the layers that it did. So keep that in mind as well. The other type is diatomaceous earth, or diatoms. And those of you who have heard me speak in the past, I'm all about diatoms. I think that they are in many ways the missing link in our healthy soil system at this point in time. Before the great expansion of humanity, all the rivers and creeks and lakes had herds, massive herds of animals running through them, dragging up all of the aquatic food web, including diatoms, up onto the land. Think about migratory birds. I mean, there's stories and pictures of the late 1800s where in the Carolinas, the sky darkened with the migration of these geese and ducks, and those migrated all over the country. So as they took off and landed to eat grass, all of the aquatic soil food web and diatoms were spread across the soil system. And of course, nowadays, we don't have those massive herds or those massive migrations. So in many ways, the diatoms and the other parts of the aquatic food web are not getting up on the soil. Now, a quick little flashback, and NASA did a study in 2011 about the dust storms in the Sahara Desert. And what they determined was that dust went all the way up into the upper atmosphere, floated across the ocean, the Atlantic Ocean, and reformed into particulate that rained down on the Amazon rainforest. And that study indicated that they believed it was providing phosphorus for the Amazon rainforest. Another study that was done, I believe, in 2017, where they took it a little bit further, and they realized that it was really diatom shells, as well as some silica sands, that were raining down on the Amazon rainforest. And so now the theory is it's more fertilizing the system. So again, these diatoms are very important in the whole ecosystem. And I want to touch on diatomaceous earth for a minute. Now, that is where diatoms have been collected or mined. Specifically, if you look at some of the interesting satellite photography about the glaciers melting, you will see these huge plumes of diatoms happening where that mineral-rich water hits the ocean. And so they plume out, they grow until that minerals are depleted, they die off, and they leave a huge layer of diatomaceous earth on the seafloor. And then as the continents move and drift, of course, billions of years, eventually those pockets of diatoms end up on the surface of the earth instead of underneath deep water. Now, people use diatomaceous earth as a insecticide, and it does have pretty effective properties. Quick story of when I was young, I got to tour a glass manufacturing plant, Foster Forbes Glass. I think it was Hopedale, Massachusetts. And out back, there was this huge pile of glass that had, either screwed up and dumped on the floor, or bottles that weren't quite manufactured correctly. And they would just throw them back out in this giant pile and then pull from that as they needed it to recycle it back into the glass production system. And we laughed about what torture it would be if you were forced to climb up over the top of this mountain and down the other side. What would be left of you? And so that's basically what diatomaceous earth does to micro and macro arthropods. It basically cuts them up, shreds them. And so I've had people in the past say, well, I want to amend my soil with diatomaceous earth. And I'm like, well, I don't think that's a great idea. A little bit is okay, but if you start using a bunch of it, you are going to restrict the ability for that soil system, the soil food web, to function at its full capacity. In other words, if a nematode brushes up against one of those, it's gonna get cut open. And same with some of these microarthropods that are beneficial. You're going to lose them. So again, everything in moderation. A little bit is okay. Preferably get live diatoms, and we will be talking about those at length in the January session and how to wildcraft them or grow them out. And so in that case, you're providing a living animal into your soil system. And again, the interesting thing about diatoms are is they actually produce oxygen. That is their off gas. So if you put them down in your soil system, you're feeding oxygen directly to the soil food web that's underground and will consume that oxygen and release CO2 for the plant. So again, you're assisting in the gaseous exchange or gas exchange system that functions perfectly with plants. Another interesting thing about diatoms is they have a biogenetic bond, not a covalent, not an ionic. So a biogenetic bond is easier to be broken apart. And therefore, again, now you're mining silica and other minerals and nutrients a lot easier than perhaps trying to digest a grain of sand. Silt, all right. Silt holds a negative charge. And here again, here's the dogma of soil science. Sand does not hold a charge, but silt does. So why are they defined by particulate size? Another interesting piece of understanding why it's valuable to have a paramagnetic charge in the soil. Think about how you can attract nutrients and store nutrients so that they're not mobile in the soil profile. Well, a negative charge will help tremendously in holding a cation. So positives and negatives attract, the same positive and positives repel. So if it's holding a negative charge, then it's going to be attracting a cation. And we'll get into the specifics of that in another slide or two. But also another piece of this to think about is that how do you form aggregates? And aggregates are the key piece to a healthy soil system. Aggregates are formed generally through either a positive and negative charge, helping to start attracting particulate together. And then the next level is what happens with bacteria. They create a biofilm, which helps to bond these particulates together. And on the fungi kingdom, it's glomalin. It's another form of natural glue that will help bond things together. And in understanding the physical properties of soil and remembering that only 50% of that is physical and the other 50% is water and air, it's really important to have that aggregation so that water can infiltrate and gas can exchange. So aggregation is critical, and silt is a big piece of helping to form aggregates, micro and macro, in your soil system. Another thing that can take into consideration is silt is an organic matter. It just happens to be very fine. So what comes after silt would be humus, and then humates, and then humic acids, which are a part of humate process. And so you're, again, providing a very valuable nutrient in your soil system when you do include silt as part of your soil recipe. Clay is one of my favorite. I will bounce back to when I was a kid. We used to mine clay on the side of a hill on a road, and we'd get this really white, almost like anyone out there who's painted and used white paint, if you put just a tiny drop of purple in there, you get like a three-dimensional white color. And so primary clay is white, or this kind of like interesting color of white, not just flat white, has some depth to it. And primary clay has very little minerals or nutrients. It does have a charge, but again, it's not as valuable as some of these colored clays. I've seen blue clay, I've seen green clay, I've seen red clay, I've seen brown clay, and I'm sure you all have too. And the beauty of clay is that it's both negatively and positively charged, which I will get into in a minute. But more importantly, backing up, clay expands when it gets wet. So it has a water holding capacity. And it also contracts when it dries out, and that contraction can cause problems and compaction. So if you look at the center of this slide, you'll see how the clay platelets stand up on top of each other. The outside edge is positively charged, and the flat surface is negatively charged. So imagine if you took the piece to your left and stacked it up on top of that other clay platelet that's upright. Now you would form what I would call an I shape. And some of the interesting studies I've been reading on is that that little C-shaped, negatively charged or paramagnetically charged area is attracting, guess what? Cations. So those are nutrients. So if you stack these up on top of on themselves indefinitely, which is what you will have in a healthy soil system, think of all of the potential nutrient holding capacity clay provides. Again, it's not mobile. It's not going to wash away. And as those root tips and root hairs hit those areas, they can actually pull those nutrients out. And they're essentially plant available. They have been processed at that point. And again, clay helps in building aggregation, which is the critical piece to that gas exchange, water infiltration, water holding capacity. Now, let's talk a little bit more about the clay platelet and CEC. CEC is the measurement of three primary nutrients: calcium, magnesium, and potassium. And I know a lot of cannabis growers in the past were always, CalMag deficiency. Well, it really isn't CalMag deficiency. It's CalMag and potassium. If these are out of whack, you're not going to have what would be considered a perfect, healthy soil system as far as these nutrients are concerned. There's a lot of tests that you can do, but this is one that has been, for the most part, overlooked. It's called the saturated paste test. Now, there's 100 parking spots on a piece of clay. And in an ideal situation, you have 75 parking spots filled with calcium. You have 18 parking spots filled with magnesium, and you have 7 parking spots filled with potassium. That equals 100. And that's what the saturated paste test is measuring for you, is the understanding of how well your nutrients are balanced within, or your cations are balanced within your soil system. So clay provides that. And so if you're building a soil system, then to not include clay, in my mind, is a mistake. And I understand a lot of people are scared of clay. Heavily clay soils are difficult to grow in. They're nowhere near as hard to grow in as sand is. Trust me on that. But there's issues with clay that if they're compacted or dried out or heavily saturated, then they can erode, they can create anaerobic pockets, they can collapse and compact and not allow gas exchange. So I'm not saying use a ton of clay, but there is a formula that I've come up with, and I'll talk about it in a little bit, about how to use clay in your soil system without having these kinds of compaction and water storage issues that can come into play if you have a very heavily clayed soil. Soil organic matter. All right, so this is the last of the 4 parts fraction. All right, sand, silt, clay, and organic matter. Those are what make up all soils. Organic matter, or we call it soil organic matter, SOM, is critical in fertility. It's a source of all nutrients because all plants pull different nutrients, and as they break down, they make soil organic matter. And so if you do not have a lot of soil organic matter in your soil system, then your fertility is somewhat of an issue. And, ironically, I'm bouncing around here a little bit, but traditionally it's considered to be a very healthy, fertile soil if you have 5 to 8% soil organic matter in your farm. And personally, I think that's low. I mean, I've done a lot of soil engineering in the past, and I did push the limits a little too far on one particular project. It was okay. I was experimenting with some architectural plants that should never have been planted together, and I was trying to balance it out so that a swamp maple could be grown right around boxwoods. And so I used a tremendous amount of soil organic matter to hold that moisture in and lock it in around the roots of the swamp maple, and then used a lot of sand outside of that to help drain the boxwoods so that they didn't have root rot. And what I came up with after the fact, we went back and looked at the soil, and it was very gummy and sticky. And basically what that is that's the biology doing their job. But it can become an issue in a situation where if you overwater, you're going to go anaerobic. And in this particular case, that's what happened. And the tree started to suffer. So we went back in there, analyzed the irrigation. We actually removed a tremendous amount of drip around the base of the tree and only had one small strip so that when the watering came on, it was not putting as much water into that swamp maple's soil profile to avoid that anaerobic condition, and it worked. It was fine. But there's a limit to everything, and you don't want to get into a position where you have stepped over the boundaries and you're going to cause yourself further problems because you were in excess of something. So on the right, you can see what actually soil organic matter is composed of. Carbon, which we all know is a very important food source for microbes. And also oxygen. I mean, look at the percentage. It's pretty much carbon and oxygen with a little bit of hydrogen and a little bit of nitrogen. Now I want you to flip these around and look at nitrogen or carbon to nitrogen. It's called C to N ratio. It's an important other measurement for maturity, and we will get into that in another slide. But it also is the foundation of life. Everything has carbon and nitrogen to a ratio. And then in the middle, you have oxygen and hydrogen. Well, we all know when hydrogen and oxygen get together, you have water. So essentially, soil organic matter is the food source. It has the carbon to nitrogen as well as the oxygen to hydrogen. It's everything that you need to support life. So again, I want you to start looking at these constituents, these pieces of the soil system in a different light. It kind of, this is why things function so well when they're not disturbed or not overused or abused. And unfortunately, we have done horrible damage to the surface of the earth, the living skin. But we can start to fix that. And specifically, in cannabis growing, cannabis production, you want to have these pieces in play, and you don't want to be in just a soilless medium anymore. I think that, we've all learned that there are better ways, and we just have to get out of our own way and start thinking that there are better methods and techniques if we biomimic nature. In other words, copy what nature has already shown us is extremely effective. Soil horizons. I first introduced this about 4 years ago at the conference that Daniel was referring to. And I pretty much got laughed off the stage. Cannabis growers didn't get this. And I think now, after 4 years, Shango Los, I love him to death, did a podcast on this. And it kind of opened people's minds up that, hey, maybe this is a better way. And the people that I've worked with and consulted and or explained this to, who have used this technique, have had great success with it. It's prevented them from overwatering and underwatering. It's taken the curve out of, having hydrophobic soils or anaerobic conditions. So it really is, again, a better method to growing a plant, especially a heavy eater like cannabis. So at the top of the screen, we have the O horizon, and that's traditionally would be considered a soilless medium. So it's all just pure organic matter. The A horizon is the critical one. The A horizon helps to mitigate excess moisture that is put on the organic matter and lets it drain down in throughout the A horizon, where some of it's stored, and any excess is again allowed to escape down into the E horizon. I have the B horizon in here because I wanted you to understand that there are many other horizons, but for the most part, on the right, you will see O, A, E, and that's the ones that I really want to focus on today. So let me explain a little bit more about how this system works. Traditionally in, the early, 1500s, a lot of wealthy kings were starting to do amazing topiary, where they were growing these plants in pots and making incredible shapes and sculptures out of these living plants. And one of the most important parts that they did was to add a drainage layer at the bottom of the pot. And a good old friend of mine who's since passed, Wallace Gray, who actually did floral decorations for the Queen of England. And he had pictures of these things. I mean, they were like 12 feet tall, and they were all wire and fresh flowers that he would be assembling when the Queen had dignitaries coming into town. And he used to talk about how he potted everything, and he would take his old spent clay pots that were cracked or chipped, and he'd smash them up and put them in the bottom of the pot, essentially creating an E horizon. And I think so this tech has been around for a long time, but it has not been brought into mainstream, especially in plant production here in the U.S. for the most part. So the E horizon, or that smashed up clay, allows an area to store water. And when I recommend people build an E-Horizon, I tell them, all right, if you're in an 18-inch pot, you want about a 2 to 3 inch E-Horizon. So that means you want to use rocks the size 2 inches, no bigger, and put them into the layer, put them in the bottom of the pot to between 2.5 and 3 inches. And then I want you to take a coarse sand. And by coarse, I mean not super coarse, but not super fine, not that white powdery stuff. That stuff is problematic. You want to look toward a medium particulate size. It should be gray or amber or yellow or taupe. That indicates a good mineral content, like the calcium carbonate. And you basically pour the sand in there and water it and pack it down until you're at the right height. Again, 2.5 to 3 inches. Then the next layer on top of that is the A horizon. And as you can see on the bottom left, you see 3O, 2A, 1E. And this is the formula. This is the ratio. So again, your 18-inch deep pot, you've used up 2.5 to 3 inches. So your A horizon is going to be about 5 inches. And that is going to be a percentage of 50% sand, 17% clay, 13% silt, 20% organic matter. So it's still going to be providing you quite a bit of fluffy soil that the roots can easily penetrate. But more importantly, that blend works perfectly with wicking excess moisture or lack of moisture up out of the E horizon and pushing it back up into the O horizon, and vice versa. If you have excess water in the O horizon, the A horizon will wick it back down and get rid of any excess into the E horizon and store it. Now, the critical piece of that sand being used in the E horizon, it prevents fines from migrating down and creating an anaerobic pocket. If too much organic matter gets down into that water, what happens is that the bacteria start to mine that organic matter, and they're chewing up oxygen, and therefore you're actually getting into a situation where you're getting a low oxygen water or low dissolved oxygen in your water, which is problematic. So that sand actually is what we call a sand filter. And if anyone of you have had fish or like a pond outside, a water feature, generally you'll have some kind of filtration system, and a lot of time it's what's called a sand filter. So it pulls the what we call the turbidity or suspended particles out of the water, leaving you with a crystal clear water source for your water feature or your fish tank. So that sand is a critical component to preventing that organic matter from getting down in there and causing problems. But remember, as the organic matter breaks down, it turns into an organic acid, which is good because that acid does get down into that water system, and again suspends or slows down the biological activity. When in the past, when I was figuring out how to deliver biology to people in a shelf-stable manner, one of the things we did was play around with what's called a pH suspension. So that's using very low pH or very high pH, different compounds to get that pH down low enough that you don't have a problem with the organisms going anaerobic. So keeping that in mind, that organic acid will help support or mitigate excess biology. And again, it's allowed to get down into that soil profile because it's very small and it's liquid, and that will help to maintain that minimal biological life in the bottom of that pot. So now we have the O horizon. The O horizon is what's considered, or typically you guys call, your soilless medium or your super soils. And so we have 3 parts of that organic matter at the top. So we have explosive root growth, we have nutrient storing, we have gas exchange out of the gate. Now, eventually what's going to happen is this system will aggregate up, and now you're on the next level. But in order for you to get a positive first run, this is kind of the way you're going to have to do it, because if you just plant into potting soil, and we'll get into that in further detail, and I'll explain the complications with just doing that. So think about soil horizons as you move forward in your life, and you're starting to either add on more beds, or you're going to, you're taking over facility, you want to set up an indoor grow. These are the things that you should be thinking about. Micro and macro aggregates. All right. What are they? Well, they are the function of soil. And we now know that the inside of a aggregate is most likely positive or negatively charged, and the outside is opposite. And then that charge is gradated from the outside to the inside. And why is that important? Well, again, we know that magnets attract things, those cations and anions. So that's basically, again, nutrient storage capacity. And also, if you look at the pictures, you can see how there's little pockets. There's air spaces. There's pores for moisture or water to get down into it. When I do consulting, a lot of times the first thing I'll do is an infiltration test to see how well water can infiltrate into your soil. If it can't infiltrate in, then it washes soil away. It's called erosion. And so that's why aggregation is so important. It really provides that next level of function in a soil system. Again, soil is only 50% physical. The other 50% is its ability to hold moisture and have gas exchange. So that's the critical part that you need to keep in mind. Now, everything starts with a microaggregate, but again, the outside is either negatively or positively charged. Well, guess what? Two microaggregates can come together magnetically, and then the biology sets up its glues, whether it's the glomalin from the fungi or the biofilm from the bacteria. And now those two microaggregates are starting to form into a macroaggregate. So it's a combination of both the paramagnetic charge as well as the biology that are really creating these aggregates and moving them into bigger and bigger components. Recently, I've started using the word rhyosheath. And I think everybody knows what this is. Anyone who's walked outside and picked a weed, and there's this big clump or ball around the root base, well, essentially that is a rhyosheath. And you can imagine that that's like a vast city, an entire community of its own microbes and nutrients and minerals and water storage capacity. Again, positive and negative charges. So to have a rhyosheath around your cannabis plant is what you're looking for out of the gate. So right as you start, as you continue to use these containers or raised beds, these aggregates will continue to get bigger and bigger and bigger. This is why I always say to people, do not remove your root balls. Just cut your plant off at the surface of the soil and leave it in there. And you'll see that how quickly that will break down and turn back into organic matter. So if you rip that root ball out, you've totally disturbed the soil system. You've wrecked all your aggregation, and you've damaged your biota. I mean, when you remove that out of there, you've taken the vast majority of your rhizosphere, which is all where all of your advanced microbes live and do their work cycling. So again, always leave your root balls in the ground and just plant next to them. Chances are they will disintegrate within a few months, if not by the end of the next cycle. So how can we form these? Back when I was just finishing up my work with the Lane down at Rodale, she introduced me to a gentleman named James Sotillo. James Sotillo worked on large parks and both federal, state, and town, where they put in this engineered soil so that it wouldn't compact, so that people could walk around the monuments or to walk down the paths or the parks and enjoy a nice stroll without either getting sunk in the mud or without having, no plants being able to live there. So they did what was called a 90-10 mix. So 90% sand, 10% organic matter. Now, the only problem was after a few years of fertilizing it, so understand that if you use ammonia as a fertilizer, the microbes will actually have to consume carbon first to metabolize the ammonia and allow it to be plant available. So you're burning carbon. You're burning organic matter. And if you're using nitrogen-based fertilizers, you are doing something similar. Now the microbes need excess water to break down that nitrogen and make it plant available. So now you're overwatering, or you have to use a tremendous amount of water. And either way, what's happening to your soil system is you're washing your fines down, so you're losing organic matter that way, or they're getting chewed up by the microbes. And so after a number of years, you basically now have few patches of grass, a lot of bare soil, and a bunch of weeds. And that's not aesthetically pleasing on these, multi-million-dollar parks and tourist attractions. So his job was to try to figure out how to get that biology back into play. Saprophytic fungi, nematodes, protozoa. And his problem was every time he used a GOT brewer and every time he applied his tea, it just washed down the profile. So they'd come back 2 weeks later, do a soil test, and see that there was none of the organisms that he had put in play 2 weeks prior. And so that's when he and I started talking about what I was doing, which was actually taking compost and putting it in a washing machine, believe it or not, and stripping the biology. One of the products that came out of that was a highly concentrated biological humic acid, and it was supercharged magnetically. So what we did is we applied this humic acid pretty heavily. So it was like diluted maybe 5 parts to 5 parts water, 1 part biological humic acid. And right away, everything started to bond together. All the particulate sand specifically was starting to bond together. There was a little bit of clay that comes through the process when I do the actual washing, so that we were adding a little bit of clay, and we were adding a tremendous amount of bacteria to start building those micro aggregates through their glues, and it worked. And 2 weeks later, he came back, and the top layer of that sand was now brown. It had started to bond together. So now he could apply his GOT brew, and the organisms would stay intact and in play. And he'd come back 2 weeks later, he'd do his biological test, and sure as shit, all of the players that he had installed were present. And it took about 6 months, maybe 8 months. And now that soil profile was down about 4 to 6 inches. The grasses were all coming back. They were not using the nitrogen sources or the ammonia sources anymore, which prevented the killing of these biology. And lo and behold, the park was holding up. They could have their movies and have crowds of 10,000 people marching across it without any problem. So that is how you form those aggregates out of the gate. But in the situation, as we just talked about, it's better to actually use soil horizons. Now, they could not rip up all the soil in these parks, so we had no choice but to try to figure out how to make it work. So if you are in a situation where you have heavy sand and you're trying to grow cannabis, this would be a good trick for you to get that aggregation process to begin very quickly. Again, it's not an end-all be-all, because you're trying to grow this plant at the first go-round. So in that situation, you'd probably have to do both a humic acid installation, biologically active humic acid now. You'd have to do that first, and then a cover crop to really start to push roots down and get those aggregates formed, so that when you did do your first run, you didn't have any issues. All right, CEC, cation exchange capacity. This is another unit of measurement used in soil testing, and we talked about it briefly when we were in the clay particle part of this conversation. And I want you to look down cations on the left-hand side of the picture at the bottom. Look, calcium, magnesium, potassium. All right, so those are those pieces that are so important in soil fertility. And if they're balanced correctly, the only other piece you really have to be concerned about is your micronutrients. On the right side, we see anions. Sulfur, which is very important, phosphorus, very important, nitrite and nitrate are very important. Now, we do have some issues with fluoride and chloride, and that's why it's really important that you're making sure that those anion sites are the things you want and not the things you don't want. Same case with cations on the left. Sodium is a big problem, but if you notice, sodium is only single charged. So you have other minerals and nutrients down the bottom, calcium, magnesium, who are double positive. So they will actually push salt off of that clay platelet if you flush it. And then you add the appropriate levels of calcium and magnesium. But again, you got to be careful not to get things out of whack. So flush it, try to get rid of as much salt as possible, and then try to put down the best balance based on your saturated paste test you can, in hopes that those will repopulate in the correct amounts. So interesting understanding is that higher pH will actually have a higher CEC, which is something that's always fascinated me, because in redox potential, which we will touch on in January, you're looking for low pH, low EH, and high EC. And so to think that fertility is regulated in some degree by a higher pH is always complicated, or confused me. But I just wanted to make you aware of that chances are in a higher pH, if you're pushing 7s, you actually are going to have a higher CEC, higher rate of fertility. And then obviously the higher CEC, the less fertilizers you need, the less amendments you need. And that also goes true with how much can be stored. So remember, we have 100 parking spots, but if we have hundreds of thousands of those sites to park on, well, of course, we're going to have a lot more fertility in the soil. So the measurement of CEC is important to take into consideration when you're doing your soil test, along with soil organic matter. What is that percentage? And then, of course, your saturated paste test, and then your micronutrients. If you can get a handle on those 4 key tests, you're going to be way better off out of the gate, and also in amending, so that your next go round. Now, we know for sure different cultivars pull different nutrients. So if you're using the same cultivar over and over and over again, then you're definitely depleting one of the nutrient pools. And so this is why it's so important that you do soil testing. Chip's going to bang that home with you guys later today, that without knowing what's going on in your soil, how can you properly amend? You're either over amending or you're under amending, and both of those cause issues. So again, I know a lot of you guys complain about the cost of this, but what's the cost of having a failed crop or a reduced yield in your crop? I think it's far greater than the cost of a couple tests during either right before and then right after, so you know how to amend it for the next run. Again, cations are positively charged, anions are negatively charged, and that's something that you want to keep in mind when you're again amending your clays, so that you or better yet, organic matter, which has both negative and positive charges. Again, those rhizose sheaths, those micro and macro aggregates have both negative and positive charges. So therefore, they're holding both groups of nutrients that you're looking for. Compost. I could do a whole week on this one. I'll try to keep it brief. Thermophilic. So basically, thermophilic compost means you're heating up compost, and pretty much what you're left with is just thermophytes. They are the bacteria that consume or decompose at an incredibly fast rate. That decomposition creates heat, and that's why it's called thermophilic. The problem with thermophilic compost is as soon as you get over 120 degrees, you're losing mass amounts of organisms. You're losing all of your diversity. You're losing your fungi, your protozoa. And so therefore, if you're heating it up to the regs, the state regs, which pretty much every state has them, generally they're telling you that you need to be hit between 150 and 160 degrees 10 times over 15 days, or each state has a different program. But bottom line is they're kind of forcing you to kill everything in that pile repeatedly. And so what you're left with is basically chemistry compost. Yeah, it still has value. It still has nutrients, because that organic matter is made up of nutrient, but it's not plant available. And you need a tremendous amount of biology to start breaking that down and making it viable for the plant. So thermophilic compost has its issues, and the same with green waste and the same with food waste. Now, green waste's particular issue is that you tend to get a lot of pesticides. traditional landscaping, which frustrates the daylights out of me, is probably one of the biggest polluters on this planet. Between the nitrogen they're using, the gas-powered equipment that they're using, of course, the Roundup they're using, and or potentially other insecticides or herbicides. It's a nightmare. And when you take this stuff and you compost it, you're not getting rid of anything. You're in many ways kind of concentrating it. Now, I know they tell us that, hey, the half-life of this stuff is a lot less than it used to be. But again, it's like making a concentrate. All you're doing is concentrating everything more. So I do still use a little bit of green waste compost or thermophilic when I'm making compost, because I want those extra nutrients, but I limit the amount that I use. So again, small or less is more type philosophy. I still want the diversity, but I just don't want all of the problems that come along with these types of systems. Food waste is really scary. I mean, you have to really cook the hell out of this stuff to get rid of all of the pathogens. I've had the pleasure, and I'm sorry to say, I've actually worked with Merck Pharmaceutical, the bad guys, the evil empire. And they had a campus back in New Jersey where they wanted to be more sustainable, and they were taking their food waste and putting it in this rocket composter. The Rocket is the brand name. And they were having all kinds of problems with it. And so a gentleman that I know well had invited me down to really kind of figure out what the problem was. And it was their feedstocks. Their ratios were way out. They did not have enough browns compared to the amount of vegetables. Now, they didn't use meat in this one. They just used vegetables and fruits, but the balances were way out. They were dumping, because they were trying to process too much too quickly. It was like 60%, 70% food waste and only 30%, 20% browns or carbon sources to start the process. So yeah, they heated this thing up, and 3 days later it spat out this compost that was stinky, nasty. It was a mess. So I had to slow them down and let them understand, well, look, you can't dump all this stuff at once. Either you need another rocket, or you need to slow down the process, which is going to mean you got to store this stuff in a refrigerator. And then try to catch up over the weekends, which they didn't want to do. They wanted to just dump it in there on Monday through Friday when everybody was there. So they did make some changes, and it did work out. But again, this compost that came out of that food waste was just horrible, nasty stuff. So we got them to start blending that with the green waste that they produced on site. Again, they were trying to have nothing come on or off the property other than people and food. And so we were able to blend their green waste with their food waste and let it compost out for about 60 days. And it was much better. Again, it was not biologically active, but it wasn't stinky, and it was mature enough that it didn't kill plants, because the first stuff that they used from the food waste, when they applied it to the plants died. And so, that's not a really good way to use that stuff up. So again, those top three, they're usable, but again, limit the amounts of that you use, understanding the problems that come with it. How to make biological compost. That has been the $1 million question. I've showed people how to do this, and they still have problems. They still struggle. So I'm going to try to explain it in an easier way for you to understand. Basically, what you're doing is you're collecting greens and browns. Your browns are 66%, your greens are 33%. Now you thoroughly mix them together in a manner that they are homogeneous, and now you got to touch it off with something. Now you need a inoculant of some kind to get it going. I've tried some ferments that have worked wonderful. So during Corona, I was locked down out here in Oxnard. So I went down and I got some kelp off the beach. I filled a 5-gallon compound bucket up about 3/4 of the way full, added water, put it out in the sun, and let it ferment for 5 days. And by the end of the 5th day, I had this, big white foam on top of it. It didn't smell nasty, but it definitely smelled funky, kind of musty. Put it under the microscope. I was styling. I had tons and tons of bacteria. Also had some blue-green algae, which in concentration are bad, but in not concentrated, they're okay. A tremendous amount of green algae, and both the blue-green algae and the green algae, if you look at them under a microscope, they look very similar to flagellates. And I also had a bunch of different diverse types of flagellates in there as well. So I've used that to pour it on my compost. Again, you have to use a compost thermometer. If you get up to 115, you should be turning it. If you hit 120, you're losing things. So don't wait till you hit 120 and then flip it. When you get up to 115, flip it. And by that I mean open up your pile, mix it thoroughly together, and then pile it back up again. I've been a big fan of a trick that Dr. Lane taught me down at Rodale, which is to take a wire cage, wire stock about 3 feet high, fencing material, and make a 2-foot diameter or 2-foot radius. No, diameter across, and then use that to hold your materials upright. I consider it as kind of like a bioreactor. So what happens is in down about a third down is we'll have a sphere of heat that is growing out those organisms. And the way you can find that sphere is using a compost thermometer. You stab it down to the bottom, you'll see it's still cool. You stab the top, it's cool. But as you slide that thermometer down into the depth, you'll find that sweet spot where the center of that bioreaction is happening. And what I usually do is I waited 2 weeks. Temperature went up to 115. I flipped it, put it back together. Temperature went back up to about 110, and then it started to drop down to about 80 after 2 weeks, or excuse me, after 3.5, 4 weeks. At that point, what I did was I opened it back up. I microscoped it. I had a wonderful population of organisms. So I took a 5-gallon compound bucket out of there, and I added a 5-gallon compound bucket of greens back in. At this point, you don't need to add browns unless you're trying to add in an inoculant. So like an inoculant, like a forest duff. I do want to caution you that if you are going to go out and collect forest duff or forest inoculant, that you wildcraft responsibly and spiritually. When you go out there, you want to say a prayer, you want to set your intentions, you want to become part of that soil, part of that whole ecosystem, and use your intuition to guide you. The last thing you want to do is collect a bunch of pathogens and throw that in your compost pile and then introduce that to your plants. So you really have to have good intentions. Yet karma's a bitch. If you go out there with bad attitude and about stripping and raping, she's gonna bite you. So if you're going to go out there and harvest inoculant, whatever you're going to take, you bring with you an equal amount. So in this situation, when I'm going to go collect inoculant, I always bring a 5-gallon compound bucket of good compost, so that when I pull that duff back, I can spread that compost layer in, kind of like a Band-Aid, and Neosporin and a Band-Aid. The last thing in the world you want to do is leave that soil exposed, because what you've done is you've created potential erosion, and you've exposed all those organisms that are right around the outside edges of that to air and sunlight, and that's problematic. You're going to kill them. So you really want to be conscious, thoughtful, good intentions if you're going to do something like that. So if you were interested in trying to get a heavier F to B, fungal to bacteria ratio in a bioreactor, that's what you would do. Is you would get some more forest inoculant that, again, you knew was good. You saw healthy mushrooms, not parasitic mushrooms, and you knew you were collecting appropriately. And then you can add that in there and let it sit for a couple weeks. Again, make sure you're monitoring your temperature. If you're getting to 115, flip it again. Otherwise, you can just use greens, and those greens will again start to provide more nitrogen, so that bioreactor will heat back up, and 2 weeks later you come back in, you can pull more material out and add more material back in. So it's kind of like sourdough bread. It never ends. Now that you've inoculated that pile, you can just keep adding those greens in and pulling material out of there. I would recommend most people to send their compost off to Soil Food Web, whether it's Soil Food Web New York or Oregon. Better yet, send it to Elaine. Dr. Lane has a lab in Oregon as well, I believe. But get an understanding of what you have, because the hardest part about making teas and extracts is that if you don't have any biology in there, then you're not going to get any biology out of it. And that's always been the biggest issue with compost teas and extracts, is that, people, I make the best compost. I I put it under my microscope. I'm like, no, you don't make the greatest compost. You make a good chemical compost, but you're not making a biological compost. And so if I take that chemical compost and I throw it in a brewer, what am I going to get? Dirty water. I'm not going to get organisms. So this is a trick on how to make biological compost. So I call them bioreactors or compost bullets, because they kind of look like a big bullet. The best way that I've found, which takes time, is to use hugelkultur. So basically, I'll get an old rotten log. I'm gonna lay it down north to south, a couple of them, no problem, and then I lay branches. I love tree tips. I do use some fallen branches that are, rotten and showing that mycelium on them, but I like the live ones as well. Those get stacked east-west. So basically I made a teepee. And the length of it can be as long as you want. The width of it should only be about 8 feet max, and the height should only be about 4.5 feet max. And so now I've got this, stick running north-south and all these little branches running east-west. So I've got my teepee. Now I throw about 3 inches of hay over the top of that, so that the browns and greens that I'm going to put on top do not fall down in and fill up that void. I'm looking to maintain that void underneath there, that tent, so that, little animals can crawl in there, and more importantly, as I'll explain, that helps to create convection, to draw off the heat from the pile. Both the hugelkultur specifically is what's called a static compost pile. You do not turn it, and if you inappropriately mix your greens and browns and that heats up, you're pretty much screwed. Now you have to pull the whole thing apart and start over again. And it's a nightmare, and you don't want to go there. So there's where it's really important that you do not add high nitrogen to this, and you do appropriately mix your greens and browns, because it is not cost effective to tear it apart and turn it. So I got my hay. Now I'm going to start mixing my greens and browns. I'm going to start throwing them on top. Yes, I'm going to add a little bit of thermophilic compost or a little bit of green compost as I move on. I'm always looking for diversity. So I'm not like going out and just, hitting an oak tree. I want oak leaves. I want maple leaves. I want some duff. I want, hedges. I want grass clippings if they are not been exposed to synthetics. So as diverse as I possibly can. I recently did a compost building program at a farm in Malibu, a Malibu fig farm. And what we did was I had these kids going around picking every different kind of green and brown that they could possibly collect. And it was a game, but the purpose was, again, we're looking for diversity. So the more diversity you have, the better that compost is going to be. So now you're piling up the greens and browns. If you can, collect some filamentous algae from a creek nearby that again is not a super fun site or heavy agricultural runoff, and throw some of that in there, or make a ferment and put that throw the ferment on top of this pile. So you want to be adding moisture while you're building it, and then as you finish and you're up to your 8 foot wide, 4.5 feet tall. Now you want to throw on a whole bunch of cover crop seeds. I often would pick little shrubs or little saplings out of the adjacent forest, plant them in there, and then straw the whole thing in and water it heavy. Now you come back 6 months later, you're going to have miles of rhizosphere. You're going to have incredible amounts of protozoa, nematodes, worms, everything. And again, the reason we piled this on top of those sticks and branches was so that we had good convection. So as that pile heated up on top of those sticks, the heat would come out the top and cool air would come in from both sides or all sides, and help to mitigate the amount of heat that was being stored in that pile. So now those are some great techniques for making biologically rich compost. Peat moss. Everybody that knows me knows I am just adamantly against peat moss. It's so detrimental to the environment. They basically took thousands of years for those peat bogs to form. They are an incredible water filtration system. The reason why that peat does not disintegrate is because, again, pH suspension. Peat moss is always, down around 4 or 5, so you do not get a lot of biological activity. There's no way thermophytes or a lot of other decomposers can live there, and that's how it's built. So it's built up over thousands of years, is because there's not anything decomposing it. Peat bogs only cover 3% of the earth, and they provide an incredible amount of clean, fresh water to aquifers, groundwater, streams, rivers, lakes, creeks around them. So for us to be mining that material, releasing the CO2 that happens when we rip up the mine, it's a triple negative. And now you're moving this stuff all over the place and creating a huge carbon footprint. So please stop using peat. I understand that it had its place in the day, but we have new alternatives, which we're going to get into in a minute. The other problem with peat is all you well know, it goes hydrophobic on the outside and it gets anaerobic on the inside. So it's very difficult to really grow a plant and hit full potential when there's areas that are anaerobic. And of course, when you're pouring water on top, you can't get the water to go in. It does not help with your watering practices. And again, I drives me nuts when people say, "Oh, well, it's a more sustainable peat bog." No, there's nothing sustainable about mining peat, and it's definitely not renewable. So please, again, I'm adamantly against this stuff, and I'm going to show you some other sources that we can work with to replace peat. Cocoa coir. It has its issues, and anybody that's used it in the past, generally most of it was coming, or 99+% was coming from the Far East. And so the coconuts over there are grown in brackish water, so there tended to be a lot of salt buildup in the coir. And also there was hydrocarbons. I mean, they produced this stuff over there in these giant yards where they're running bulldozers and tractors and equipment over it. So they're compacting it, they're smashing the fibers together, they're leaking gas, hydraulic fluid, oil all in it, and then they're bagging it and pressing it as hard as they can. I think they use over 10 pounds of pressure to compact this stuff and bag it so that they can ship it all over the world. They're trying to increase their profit margin by pressing as much as they possibly can into that bag. Problem with that is they destroy the fiber. The fiber itself has now been crushed. Whereas peat, they don't press it like that. And that's why traditionally peat has been a solid source of both nutrient storage capacity and water storage capacity. So in the past, coir's gotten a really bad name because of the processes in which they manufacture and ship it across the world to us. Recently, I found a wonderful source of Mexican coir. So it's not grown in brackish water. There is no salt. And he only presses it to about 2 pounds because he doesn't have to ship it across the world. But more importantly, he did studies on it. He took the time to really look at the fiber, understand how it structurally worked. What he was inquisitive. He wanted to know why this product did what it did. And he's had amazing results. So he dialed back his pressing to about 2 pounds or less per square foot, and so you don't get as much by volume as you break it up, but it functions, and it doesn't. He hasn't destroyed the integrity of the product. And another thing I really love about coir is that it has a wonderful source of potassium. Now, it's not a potassium that is mobile, so you don't have to worry about it leaching out really quick. It's bound up pretty tight in the fiber itself, so the only way it can be released is with bacterial decomposition. So again, the plant wants more potassium. It sends more exudates out for the potassium mining bacteria. That bacteria grows out, mines more material, lets it leak back to the plant, either by being consumed by protozoa or by releasing it in the rheosphere, or when they start to die off. So again, it's a wonderful source of potassium, holds minerals and nutrients great, and it breaks down really, really slow. It definitely breaks down longer. It takes longer to break down than peat moss does. Peat moss. I met Mott Hadley back probably 10 years ago at the Phipps Conservatory. The Phipps Conservatory is in Pittsburgh, Pennsylvania, and Phipps was a buddy and fellow corporate raider, along with Rockefeller and the steel business in Pittsburgh. So they made tons of money, and Phipps decided he was going to build a badass monument to himself and collect plants from all over the world, and he did it, and it's quite spectacular. Now, the Phipps was doing what I want to call more organic style classes in the back, teaching people about lawn care, and they got some pushback because in the conservatory side they were mass producing plants for their displays. Every 3 months they would go in and rip out all the existing plants, plant a bunch of new ones based on a theme: spring, fall, Christmas, New Year's, whatever. And so in doing that, they had to produce a ton of plants very quickly so that they could flip out the displays. So, of course, they were using synthetics. So with that pushback, they called Mott in to provide a more sustainable plant matrix than peat moss. And they brought me in to provide them with a high level of biology in hopes that we could have them reduce their synthetic footprint. The experiment ended in what I want to call, in their mind, a failure. In mine, it was a lesson. I don't think there's any such thing as a failure. They're all lessons. And what happened was the biology just set up shop on the peat moss and did not have an association with the plant. So it was, in my mind, a wonderful soil amendment, but not an ideal substrate to grow plants without fertilizer. Kind of like peat moss. If you don't add something to the peat, you're not going to get a wonderful plant because there's no nutrition in peat. So the lesson we learned was that this first round formula wasn't ideal for biologicals unless you were using this as a soil amendment, and you wanted to give more organic matter and homes for biology to set up shop, grow out, colonize, and then create those aggregates. So recently, I was on a podcast, I was on a podcast this spring, and I got, lo and behold, I got hit up by a girl named Ashley from Peat Moss, and I was like, whoa, I always wondered what happened to Mott. He Shark Tanked and made a bunch of money, got a bunch of grants, and then he just disappeared. I didn't know what happened to him. And she's like, yeah, well, things didn't work out with Mott, so we've the investors taken over Peat Moss, and we've hired Dr. Charles Bethke as our soil chemist and formulation man. And we've got a new CEO, Brian, and I'm here in charge of marketing and sales. So I'm like, wow, great. What have you done? And she said, we just spent 3 years reformulating. I'm like, fantastic. Send me out what you got and let me play with it. So the first tests I did side by sides were water only. One of the products was a little bit better than the others. And the second one was biology. When I did the biologicals, and again, what I did was I used this material and I used grass seed, something that would grow quick that I could see plant reaction with. And the grower's grade was close second, and the Cocoa Complete was by far outperformed the vast majority of their products. I don't know exactly why. My gut feeling is the potassium as well as the structure of it. The core adds to the grower's grade. Now, the grower's grade is just pretty much ground up newspapers and cardboard boxes. So a waste stream that definitely needs to be utilized way better than it is. Now, this product is sustainable. It is regenerative because you're eliminating waste material from getting into landfills, and it works wonderful. So here is a perfect example of a material that you can use to stop using peat moss and stop the mining. And remember, as soon as you stop buying it, they're still going to mine it. They're just going to pile it up to a point where all of a sudden it's still sitting there and no one's buying it. So the sooner you stop using this, the sooner they stop mining it. Again, the nice thing about Peat Moss is that it does break down slow, but it does provide that water storage capacity. It provides a wonderful source of carbon for the microbes to set up shop and mine and build those glues to form those macro and micro aggregates. Soilless mediums and hydroponic soils. I think we've all kind of learned the lesson of these. 1/3 peat, 1/3 aeration, 1/3 compost. Yeah, they work great. You do have to add nutrients to them. You do have to top dress them. Biggest problem with these systems is they do go hydrophobic and they do go anaerobic. I don't think they're ever going to form any kind of aggregation. So, and the other piece too is that they lose volume as they break down and get in, the processes, the biological processes of breaking this down creates a tremendous amount of fines. And those fines, as you water, move through the soil system to the bottom of the bag. And eventually you end up with a muddy anaerobic layer at the bottom of that pot. And I think, we really need to rethink that allowing that kind of surface area to go anaerobic. What happens when the roots grow down there and they touch it? Well, first they excrete their border cells as a protection method, but now the root tip is even more vulnerable. And so if that didn't work at holding the anaerobes off, now the anaerobes can have direct access to melt that root tip. And how are you ever going to hit plant potential if your roots are not functioning at the top that they can? And I think that's the goal here, is to really try to figure out ways to give that plant everything it possibly can have to express itself in its fullest way. I mean, don't all humans want that? Don't all plants want that to be able to live its fullest life and to its greatest potential? And so I don't think these soilless medium and hydroponic soil systems will ever provide that to a plant. Now we get into super soils, and I think that was a great advance over the original, 1/3, 1/3, 1/3. I mean, yes, that's the base of it, but now they've added in a bunch of organic solid nutrients or minerals, and letting the biology break it down. So instead of using a bottled nutrient, which we all know, yes, you can get organic ones, but again, you're contributing to, a giant carbon footprint. You're spending a lot of money that you don't need to spend. And you can do that you can grow plants without using those bottled nutrients. And this was a great alternative to bottled nutrients. And that was that they provided the right level of minerals, oyster meals, crab shell, seaweed extract, you name it, feather meal for nitrogen, blood meal, everything that the plant needed for its cycle was put into the soil. And basically you were biology or compost tea, compost extract, and water only. And the biology did the work for breaking down those raw minerals. That's always been the biggest beef with organic nutrient supplies, is that people throw it on their lawn and say, oh, well, it doesn't work. Or they add it to their pot and it doesn't work. Well, if they don't have the biology to break that down and make it plant available, then of course it's not going to work. It's just going to sit there in suspension. So that's where I think super soils really took it to the next level. And people understood that they still needed to get the biology in play, but everything was built into the soil system, so they didn't have to use these liquid nutrients, which were so expensive and questionable at best, because you never really know what goes into the bottle. And that's why I'm a big proponent of like Dragonfly Earth Medicine. They're all about take what's on your farm. If you need a nutrient or a mineral, take it from your farm, find it. And that's great if you have farm. If you don't, if you're in the urban environment or suburban environment, now you got to bring stuff in, but you really need to know your source of what you're bringing in. I recently worked with a gentleman in a farm in Illinois. He brought in compost that was supposed to be the best on the planet and blah, blah, blah. And he spread it on 60 acres or 30 acres of land and killed everything. It was a very immature compost. And that was something that I didn't get into above, and I should have. But, we'll get into it in the C-to-N ratios, and we'll talk more about it then. But I'm not going to spend a ton of time on super soils, but I think they were a big advance in just traditional, soilless mediums. C-to-N ratio. Here we go. All right. So top right corner, bacteria are 5.5 carbon to 1 nitrogen. Fungi are 8.3 carbon to fungi to nitrogen. So here's those ratios, and this is why it's really important. So top right, you see organic examples. So we see blood, fish, and soy meal. All right, and now go slide across the chart to the left. You see the ratio is 5 to 1. Now, what that means is that the lower C to N ratios, the more mobile. They use the word mineralization. Well, mineralization is essentially mobile. So if you pour blood meal or fish meal or soybean meal on your soil and then you water it, you're moving it through the soil profile. And if you overwater, you've washed it right out of your soil system. So that's why it's important to understand these C to N ratios, because they're going to provide you with short-term and long-term sources of minerals and nutrients. The sweet spot in the middle, you see mineralization, you see immobilization. Well, obviously, immobilization means it's slow to break down. Well, the sweet spot in the middle is equilibrium. You go down to the middle where it says 20 to 1, and I want to focus on this one. That, in my mind, is a sweet spot. A little bit more available, but not going to be like mobile in any way. They use the term rotten manure. That's not responsible. It's not rotten. Rotten would mean it stunk or it was fresh. All right. It's composted manure, aged manure. And this is where that gentleman, friend of mine or client, ran into a problem because the compost that he received was not mature. It had a too high of a C to N ratio. So it was extremely mobile and it burnt his plants and roots. So that's something that you really need to keep in mind when you're purchasing compost. Make sure that you get the most accurate test data you can. I personally, when I'm going to buy compost in volume, I go to the place where I'm going to purchase it. I tell them to make me a pile of it and don't touch it. I mark it in my mind. I remember how much volume was there. And I personally send it out for a soil test. And that's what I'm looking for, is a C to N ratio, the maturity level, which is the C to N ratio. So again, if it's too high in carbon, it's going to take forever for it to break down, which is a slow release. And if it's too low in carbon C to N ratio, then it's immature. It's hot. It's going to fry things. It's going to heat up. And you don't want any of those to happen around your plants. So take your time on this slide. I mean, right in the middle there is your composted or aged manure and your compost. You need something quick and fast. You got clover and vetch, which are a little bit slower to move through the soil system, but they will give you a bump out of the gate. And then, of course, straw is, we all know the benefits of straw. I've seen a tremendous amount of straw used in the cannabis production industry as a way to prevent soil from drying out and prevent ground cover from coming up and creeping into or weeds to causing problems. And the best part about straw is it breaks down slow. As a matter of fact, I'm working on a strawberry project out here, which I'm really excited. Harry's Berries. They're sold actually nationally, and we've tried to come up with a alternative to plastic mulches. There's 20,000 acres of plastic, double layered plastic mulch being used right around me here. And to be able to take that off the shelf would be wonderful. But that's why they call them strawberries, because they had to have the straw underneath the berry plant. So when the berry grew, if it wouldn't touch the soil. If it touched the soil, the bacteria would start to consume it, and the berry was no good. So straw has always been a wonderful material that is very immobile and does provide long-term fungal food as well as some biological foods. So definitely keep this C to N ratios in mind. Humic acid. All right. I love this product. It has so many benefits, and we're gonna try to define it. So humic acid is still very difficult to describe. We don't know all of the properties of it. What we do know is there's 3 forms of this organic acid. One is human acid. Believe it or not, that's fact. Then we have humic acid, which is a smaller fraction of the molecule. And then lastly, we have fulvic acid. So it goes in that order from large to small. Human has wonderful properties in building soil structure, but does not have a lot of other benefits other than that. It's very slow to break down, which again is good when you're trying to build aggregation. But again, it doesn't have a lot of the other properties that humic and folic do. The thing you need to understand is the vast majority of humic acids are mined. So it's basically lenadite or brown coal that they take out of the ground, and then they use acids and bases to break that down into a liquid or powder form. I'm not a big fan of that process because what is the residual? What are these industrial acids and bases they're using, and how much is it coming through in the product? How much is that product contaminated with those things? I love bioag. Dr. Faust has done some amazing work over the years. As a matter of fact, he's kind of the guy that pioneered humic acid here in America. They'd been doing a tremendous amount of work on this over in Russia for years. And when he kept running into dead end after dead end here in America, trying to find people that had been working with it and studying it, he ended up going to Russia and start working with the Russian scientists to up his game, to understand more about this and how to go about getting it. And he did some amazing work with it. And what he quickly realized was there are certain pockets or veins within the lenadite or the brown coal that have value, and others have no value. And that's the problem with humic acid, is you don't know, because we don't have enough data and research on it, whether this is going to work or not. And that's why I love Faust, because he's done the work and he's done the trials, and he understands where, if he just goes off a meter in his mining process, that he's going to have a problem. And the other thing he's done is he's introduced biological decomposition or fermentation to release the humic acid and the folic acids. So if you want to buy something off the shelf, I highly recommend you use those. I mean, there was a huge, gold rush, for lack of better words, when humic acid really started to become popular and people became aware of it. A lot of big boys jumped in the game and started ripping up the surface of the earth and pulling out these coals and acid base and hell out of them, with no understanding as to whether that product was going to work or not. And after they've invested all that money in mining it and producing it, don't tell me they're not going to sell it because it doesn't work. They are. They're going to lie, cheat, and steal. So you really, again, need to know your source of this if you're going to purchase it. Soil building structure. I talked earlier about my work with James Sotillo and how we were able to achieve a wonderful surface aggregation very quickly with the application of the humic acid that I made. Again, I'm making it by stripping compost. So I'm stripping it off of the biomass of a well-made compost. So it is a plant-based, fresh humic acid. Is not mined. So more regenerative. And anybody can do this at home. There's a number of different ways. I mean, I've seen guys, use everything from 55-gallon drums, plastic drums, PVC pipe, and they just pack it with either compost or leaf mold, which is basically ground up leaves, and or just inoculant, or just stuff around the property, around the yard, mulches, whatever browns they can find. Soak it in water for a couple of days, and then pour it off or press it. And either of these techniques will provide you with a homemade source of humic acid. And you can get crazy. I mean, you can put it in a 5-gallon compound bucket and use a mortar mixer and a cordless drill and just beat it up for a little while, and you will make this homemade humic acid. And if you have good compost, or if you have good biology in the materials that you went in there, guess what? You get all those as a bonus. So I would encourage you to do it yourself at home, but if you're on a large scale, that might not be possible, and therefore you might need to purchase some of this stuff. I would send you to Bioag and Dr. Faust's products. Another nice product or benefit of humic acid is it releases calcium. We all know how critical calcium is in the soil. And if you had a calcium carbonate sand and you added humic acid, guess what? You're releasing the calcium plant available. Again, you don't want to do too much of this. It's not about more is better. Don't be a moron. Less is better. Go low and slow, and wait for plant reaction before you continue. That way you won't get in too much trouble. Humic acid is also a wonderful biostimulant. So it provides food sources for biology. It helps to strengthen the acids in the cell walls, or the acids, enzymes in the cell, as well as the cell wall. Folic acid is better at than humic acid, but we'll talk about that in a minute. And yeah, the plant can uptake it. So it has, tremendous value. The benefits go on and on. Humic acid is just a wonderful product in everything from soil structure through plant health, through cell health. Another thing that this does is water bridging. I'd mentioned that water molecules are used as a method to transporting signals across cell wall, or not cell walls, but internally in the cell, and also externally. Cellular communication can happen from one water molecule to the next. And by water bridging, it's kind of like surfactants. So if any of you used a surfactant, you've noticed that the water does not bead up on the leaf. It actually coats the leaf evenly. So that's what's called water bridging. And humic acid is a wonderful product to help to facilitate water bridging, like a surfactant is. So it's almost a natural surfactant. And then again, the fourth phase of water. I really think that this is important. And again, keep your open mind. Don't listen to the haters. There's definite information here that is of value. And I think, as we, as a species, move forward in life, we'll understand a lot more about the properties of water as science catches up with, our present knowledge, or surpasses our present knowledge. Folic acid. This one has a very, very low molecular weight. What that means is that it's very easily metabolized into cells, both living human, animal, mammal, and plant cells, and bacterial. What it does is it helps to build the cell wall strength, which is really important, especially for plants. It's a wonderful foliant. And more importantly, it also provides a higher level of enzyme or acid within the enzyme to break down things. So we have that little bacteria hanging out on that grain of sand, and it's trying to just pull that silica out, release the oxygen. Well, it's going to need some strong acids or enzymes in its inside of its cell. So this is a great way to add, a tremendous amount of value and health to your plant. The dilution ratio is usually like 1 to 100. So this is like a natural farming preparation. You're not using this in strength. If you do use it in strength, you're wasting it. But the good news is, if you spray it and some of it drips off your plant, it's not going to hurt anything. It's going to actually add benefit to the soil microbes. It's not a great soil structure builder like the humic is, but it's definitely a food source for all the bacteria and all the biology. And to understand, what is folic acid? Well, because it has the lowest atomic weight of any of the other organic acids that we just talked about, means that it's really the very end of decomposition. So it came from a plant. It came from organic matter. So in some cases, animals and plants are both organic matter as they break down. So this is the very end of the cycle. And so, in using common sense to think, well, if I get this at the very end of the cycle, it's going to be very beneficial to the beginning of the cycle. And it's like everything in life, it's a closed loop. And so this is understanding that this is the very end of it, means that it's probably got great value for the beginning of it. And that means, so as your plants are growing, to apply a little bit of this at the correct dilution is a wonderful way to really strengthen the plant and give it an extra little bump. From worrying about pest attraction or molds or any of these other things. So super healthy plant, chances are you're not going to have the kind of pest pressure or issues that you would if your plant was not as healthy. Down in the picture, I just wanted you to see the color of it. The color is a little bit off in the slide. It's not orangey. It's more like amber. Like if you looked at a crystal of amber in the sunlight, you would see that golden yellow color. That's what it really looks like if it's in its purest form. How I get folic acid is basically after I've washed the compost, I screen it kind of like making bubble hash. I use 47 micron and 120 micron screens to trap the humus, humates, and particulate that I'm looking for that are super biologically charged, or the biology is set up on these little tiny pieces of organic matter. And so I've gotten all the humic acid off of them through the drying and screening process. I use a vibrating screen, and then I take that semi-wet solid and I put it into a press. And I use, again, a 47 micron stainless steel screen and wrap it up and then press it. And what comes out of there is just pure fulvic acid, so plant-derived fulvic acid. So you too can make this product at your home. If you're large scale, you don't have the capacity to do it, then go with Dr. Faust Full Plus. He can't even call it fulvic acid because we do not acknowledge that name here in America, believe it or not, in our arrogance and stupidity. But yes, you can make this at home. It's not impossible. And that is going to be a way more regenerative, way more plant available form than the ones that are mined acids and bases. Living soils. So, that's the whole point of this conversation is how to achieve living soils. And we've talked about soilless versus horizontal. Is it possible to achieve living soils in a soilless mix? Well, I said 2 years ago I didn't think it was possible, but I was proven wrong. I highly recommend you guys start following Livity on IG. That's Livity. It's a crew back east in Rhode Island that is doing some amazing medical cannabis production in 100% organic living soil systems. I started working with them. I met them in Portland 4 years ago, specifically Jeff and some of his crew. And we chopped it up, and he was making compost. And so later that year, he invited me to get together and have a conversation. And we started looking at his compost and started looking at his soil systems. And I was amazed. I was like, wow, this is really impressive. And so he was only missing the fungi piece of it. I mean, everything else was in play. He had protozoa. He had, both the flagellates and amoebas, some nematodes. That was another thing that we encouraged him to get some more of those involved. But his F-to-B ratio was a little bit low. So I had him go out and sample a bunch of different piles that he'd been making over the years to see if he had any that were really fungally dominant. And he did. And so I encouraged him to screen that and start top dressing that on all his plants. And he did. And if you look at the pictures, the bud porn that's coming off of that IG site, it's impressive. And yeah, I've enjoyed the flowers. Well, it's wonderful stuff, full of love and hard work for sure. But it is possible to achieve a living soil in a soilless medium. Preferably, I still believe that the horizontal system is going to be easier for people. You're not going to have to manage the moisture as critically because of the forgiveness of the profiles or the horizons working with you instead of against you. Jeff was able to get away from having hydrophobic situations by making sure that his pot tops were properly cover cropped. And so he's been able to do it, but he's also in a very highly controlled environment. So he doesn't have to worry about transevaporation. He doesn't have to worry about humidity or lack of it, so that his system is going to be less likely to get into a situation where it's going to go hydrophobic on the soil because you don't have those kinds of swings in moisture level or humidification or dehumidification. So this is the next really big question, is to feed your plant or feed your soil. I truly believe, based on what I've seen and these foliar nutrients that are becoming available, and again, we're going to go down that rabbit hole in January as to what's available and what's working and what's not working. But I've seen amazing things from foliar applications of nutrients. And the ones that I've played with so far, I've seen incredible impact in the microbial life as well. I lost a dear friend recently, Michael Hinden, who was working on a wonderful formula of amino acid digested nutrient sources. And, he told me about how well it worked on the foliar application of plants. So I had to try it in soil. That's just who I am. So I built 2 compost piles, or made 1 compost pile. I split it into 2. Checked it. Of course, it was, producing a wonderful level of biology, diverse biology. And so at week 2, I added his nutrient pack to one of the bullets, and the other one I left alone or just added water as necessary. And I checked it on week 3 and 4, and he had outperformed me or my system in generating organisms, protozoa, nematodes, etc. So his nutrient solution had benefit to the biology as well as the plant. So in my mind, that's a win-win. So why wouldn't you feed the soil, and why wouldn't you feed the plant? And anything that you've fed the plant in excess will feed the soil. But I'm not saying don't feed the soil also. Please include those, those crab shell and those oyster meals. Don't do it in excess. Don't be a moron. And again, test and appropriately amend. And I think that if you maintain that ideal level of nutritional value in your soil system, whether it's horizonal or soilless, you are in a better sweet spot than you are if you're either deficient or you're overabundant in something. We all know what Newtlock looks like. It's not pretty. So, again, test, and amend responsibly. But to answer, the question, yeah, soilless can work. I've seen it, and there's proof out there. Water's effect on all soils. Okay, so again, we're going to get into redox potential in January. And its effects on EH. So a low EH means a high level of electron availability, and water to some degree facilitates that. The aerometer is a unit, or is a device. It's the brand name for a tensiometer. I'm a big fan of these. I'm running around installing these things all over the place with people I work with, because I constantly see over and under in watering. And, I personally failed watering. I thought I had it nailed, and I went out there. I used an aerometer to figure out where that sweet spot was. And I realized right away I was overwatering. And so I followed I used the meter to tell me where I should be. And in the soil system that I have, I used an RT, which is for soil 18 inches deep. And basically the sweet spot is 40 for my soil type. Now, if you're high clay, it's different. Remember, I'm high sand here. I'm in Dune Circle off Dune Street in the middle of dunes, surrounded by all sides. So you have to be smart about it and understand the unit, the how to work this piece of instrument. But it's really low tech. Do not buy the blue mat one. The aerometer is better. It's not a digital device. It's a mechanical device, so it has less chances of having issues. I love Blue Mat to death, but that one instrument can be problematic with the sensors. So I think they're a wonderful company. They do a great job. Don't get me wrong, but if you're going to spend the money, please use an aerometer. It's just a much safer, less likely to give false readings. A unit of measurement. So anyway, I was watering. I've got it to the sweet spot for about 3 weeks. I was surfing perfectly through, when it go up a little bit. So as it goes up, that means it's getting drier. As it goes down, it means it's getting wetter. So I would go up a little, say to 43, 44. I'd hit it with 4 minutes of watering. It would drop just down below 40. And then throughout the course of the next day, it would start to rise up again. So I was just perfectly surfing back and forth. And then what happened was one day I got up, I looked, it was 45. I'm like, okay, I got to do 5 minutes of watering. I did the 5 minutes of watering, shut the water off, went about, got to work, and then came back an hour later to check it. And it was all the way down to 10. So I had way overwatered. And so what was like, well, how did that even happen? So I started paying attention and looking around, and I noticed underneath the roof line was wet. It was all like dripped water, kind of puddled up. And I was like, that's it. We must have had a heavy fog or a mist event last night that I didn't know about. And that water moisture or vapor was trapped in the top 12 inches, but had not had a time to get down to the sensor itself. And when I watered it, I just pushed all that water down to the sensor, and therefore it tripped. So if I had paid attention and looked around and realized that there must have been a fog event and waited until later in the day to see where my soil measurement was instead of just doing it first thing in the morning, I wouldn't have had that issue. So again, watering is critical. We've talked about it washing fines down into the soil profile, washing your nutrients away. So to get a perfect balance of water in your soil profile, so you have 50%, 25% oxygen or air, 25% water to go with your 50% physical part of the soil is ideal. And that should be your goal. Aquaponics, I'm just going to touch briefly on this. It is a really cool way of growing. It is a little bit more complicated than just growing plants in soil. I'm a big proponent of the aquatic food web. That's what I'm all about. I'm Kingdom Aquaponics because I'm trying to provide all the kingdoms in my products to you, which includes the aquatics. We're going to be doing a section in January on AMOs, which are aquatic microorganisms. I'm working with some guys back east on a fish farm, the oldest trout fish farm in America. And the products that are coming out of there are amazing. And he and I have been working for years on finding that sweet spot in Keith and I on how to get the product balanced. Some of the work that I've been doing over the years is finding out that in soil restoration, I don't want to just go straight aerobic. I want to work my way up in succession. So I'll use a semi-anaerobic product out of the gate, and then I'll push it into a more aerobic product before I go all the way to completely aerobic. And by doing this, I've been able to transition dirt into soil really quickly. But again, it's biomimicry. I'm following what nature does. So we have deep water culture, DWC. That's probably the most complicated one because what happens is the roots slough off and eventually they start to build up an anaerobic layer on the bottom, like a sludge. And to offset that, they've used air stones, a tremendous amount of air stones to build up the DO. But it still does not get rid of the anaerobic pocket. Every so often you have to pull the whole thing apart, dump all the water, clean all the muck, put it all back together. So it's very labor intensive. So DWC really has not taken off because of that maintenance issue. Flood and drains is great. I like it better than DWC, although I struggle with bell siphons. I have played with a number of different designs. I've tried to modify them myself, and I've always struggled with, they're just finicky, and sometimes they're working great, and then sometimes they just stop. So again, it's kind of difficult system to work with when you have the bell siphon. The dual root zone is a cool system. It's got a lot less issues because basically you're just filling it up and draining it down. And whether you're using a bell siphon or just a regular manual like plunger for a toilet, which I think is probably easier than the bell siphon. And the beauty of dual root zone is it gives you the ability to add nutrients into the soil. And if you're putting it in correctly, it will not ever get into the water below. The plant will use it up, or the soilless medium will hold and store those nutrients in play for the plant to use. So if you are going to go with aquaponic, I personally prefer the dual root zone as a way to give you the best of both worlds. All right. So in conclusion, I really want to stress that this is a journey. This is not a race. You really want to choose what's comfortable, what you feel it's in your wheelhouse. I'm not saying don't get a little, aggressive in going for it, But you want to make sure that you understand the ramifications of the decisions you're making, and make sure that those are responsible decisions. Unfortunately, I see too much people jump in and then they get in trouble and then they start bad mouthing these systems. These systems work. And, yesterday I tagged a bunch of farms up in the Humble area that have been doing this stuff for a long time. And what they're producing is, amazing stuff. So they didn't just jump into this. They slowly moved into this as they were comfortable. And again, make small steps. I experiment. I think that is the best way to learn. And those are small steps. So you're learning to work with horizontal systems. You're learning to work with Peat Moss. You're learning to work with some of these other tools like the aerometer. And lastly, and probably most important, is do your research. Don't just take anyone's word. The whole reason we started these conferences in the first place was because of the bro science flying around. And, I see too many people listen to, oh, I know how to fix this and do this. Don't say, okay, cool. I thank you for the advice, and then go do your research. And chances are you'll find that someone else tried it and it didn't work. And you just preventing yourself from making a large mistake. So the more educated you are, the more good, solid decisions that you can make as you move into these other types of soil and or regenerative organic practices. So that's about it. Here's a way to get in touch with me. I've got email, Facebook, as well as Instagram. So that concludes my presentation for today. And Daniel, would you like to hop on?
Yeah. Thanks, Leighton. That was amazing. You blew my mind a couple times there, and I'm sure you did the same thing for some other people. So before we get into Q&A here, I just wanted to take a minute to talk about our sponsors for this event. So, and I want to first start by saying that we were very particular about what companies we allowed to sponsor this event. We really wanted companies that aligned with the education that we're doing here, that, have really good products that are oriented towards growing with living soil. So we vetted all these sponsors pretty carefully. So Peat Moss is actually our title sponsor for the event. And again, just to emphasize, part of the reason they're title sponsors, because we really think that they've got a great product. That's why Leighton talks about it. It's not because they're the sponsor, but it's because he's actually vetted their product and he believes it's really great. And then our sponsor for this session in particular is Green Grow MI, which is a big online store based out of Michigan.
What's up, guys?
They sell a whole lot of great products for living soil growing. So check them out and check out Peat Moss. They're our sponsors for the whole event and for this session.
Yeah, and there are other paper mulch products out there, and I have tried them, but they don't have the quality that these guys did. Remember, Charles Bathke spent 3 years reformulating this to make it good. And yeah, the great grow guys up in Michigan, love them to death. Sorry we didn't get to see you guys live, but maybe in the future we can actually start to get together again.
Awesome. All right, so let's get into the Q&A here. So we've got a lot of questions, and hopefully we'll get to most of them, but we're going to start with the ones that got the most votes. So Greg is asking, when building the soil horizons in an 18-inch deep pot, do you allow the water to drain out or allow it to pool in the E-horizon?
So what I do is I actually use a container water holder, so a pot with a little plate underneath it. When you go to your local garden supply place, you'll see regular clay pots. And then you can also get the little saucers that go underneath it. So what I do is I get a saucer that's the same height as my E-horizon. And I put the pot in there so that when I water it, I can actually see what the water level is in my E-horizon. And that also helps me understand, is the E dry or not? So it's just a matter of using traditional potting methods, and it can be a plastic tub, whatever size you're growing in. If you're growing in a 200-gallon pot, then you can just use a rubber liner around the outside and a couple of 2x4s, to hold the rubber liner up. And so as that water gets down into the E horizon, it leaks out and you can actually see the level of water. So that's a trick. Another way you can do it is you can actually slide a pipe down inside the pot with a little hole at the bottom so that the moisture can go in there, and then you can just use a stick to dip it down. Kind of like you see them stabbing gas tanks at filling stations. It's another way to measure if you even have moisture in there or what the level of moisture is. And again, you don't want to ever have a situation where you've watered so much that your A horizon is now sitting in excess water. So that's why it's important to monitor that somehow, whether it's out externally or internally.
Great, and then that's a perfect segue into the next question. Someone was just asking, can you use fabric pots like grassroots for the horizon method?
Oh, absolutely. I forget which pot it was. Shango has showcased it lately. Is it the grassroots pod? But it has a vapor barrier on the inside, and that was always my biggest issue with the traditional fabric pots, like the smart pots, is there's no vapor barrier. So what happens is you're allowing that moisture to wick out the sides, and you're allowing the oxygen to dry out the sides, and that's where those hydrophobic situations come in. And you pour, water on the top of the pot, and it just runs right down the sides of the pot. You're not getting any penetration whatsoever. And, perhaps I should address what hydrophobic actually is. It's where you have a high level of bacterial concentration and of course their biofilm. And when they go into a cyst form, they create like a wax coating around the outside of their shell. And that's what repels the water. So if you have a highly biological system and it's dried out, those bacteria have gone into cyst form, and now that water can't penetrate. So with these the grass pots or whichever company it is that has the liner on it, big fan of it, because it's going to prevent that from happening to the side of the pot.
All right. Next question. Do you know what the ideal fungal to bacterial ratio is for growing cannabis?
Oh man. All right. There's a lot of work being done on this right now. And Elaine, I'm hoping she's going to touch on this. She's been doing some work in Brazil.
I was going to say.
Yeah. But bottom line is you have to understand successionally where the cannabis plant falls in plant succession. And yes, you have, what we want to call the sativa and indica. Yes, they did exist at one point. They don't anymore. We've crossbred them so many times. But one was growing up in the mountains, very dry, arid climate. So probably less F to B there than the ones that were grown down in the jungles or in the higher, more advanced, complex ecosystems. I would tend to think would be on the higher F to B ratio. But I do believe that it would be higher than a 1-to-1. 1-to-1 is typical, like vegetables, house plants. They should be about 1 bacteria to 1 fungi, whereas the cannabis plant is later in succession and therefore should have a higher level of F to B. And hopefully Elaine will get into that a little bit more.
Great. And also, I just want to make a quick note because people are still asking about this issue with the pop-up asking you to continue. I believe we fixed that now. You may need to just refresh your browser, but that should be gone, and hopefully that won't be a problem for the sessions going forward. All right.
What the
next question?
The pop-up that happened to me? Was it the pop-up that kept happening to me?
Oh, yeah, it might be. Yeah, everyone's just getting a pop-up asking them to click to continue the session. But
oh, okay. Yeah, I had that happen to me. Did you see it on my screen?
No, I didn't. But I think I figured out how to turn that off, so it shouldn't be a problem going forward. Yeah.
Okay.
So next question is: how would you mix clay into your soil?
Oh, good question. I'm going to answer this for both silt and clay. Silt is usually going to be harvested out in a wet form, and clay is often pretty wet and saturated as well. So both of these I would air dry. So if it was indoor, I would spread them out on a tarp with a dehumidifier and dry them until they are fluffy. You cannot homogeneously mix them when they're wet; they get clumpy. So both your silt and your clay should be as dry as you possibly can get them. Another thing is a trick If you're doing this at home, get a cement mixer, not a mortar mixer. A mortar mixer will not do the right job. So the difference is a cement mixer is going to be in a cone, and a mortar mixer is going to be more in like a bucket. So get a cement mixer, use a 1 gallon bucket, whatever, to do your ratios correctly. Throw it all in there, and then turn your cement mixer on, because it's going to homogenizely mix this together thoroughly. You can't do it. You can't do it with your hands. Like, I've tried. It's too hard. And the goal is to have that as well blended as possible, so that it's functioning at peak performance right out of the gate.
Awesome. All right. Then another question about kind of along this train. When building a fresh batch of soil according to your Horizon method, what total volume would you recommend per 4 foot by 4 foot growing bed? So I imagine that means total volume of each component, perhaps?
Okay. Yeah. So I would say go back to that ratio, 3-0, 2A, 1E, and that will give you the height version. As far as the actual square footage, that's something you're going to have to do some calculating on, but it's not that complicated. But I think that the depths are way more important than the overall square footage you need.
Mm-hmm. Great. And just want to note to everybody, you have access to watch the replay of this for 30 days. So if you missed something, if you want to see that graphic again, you will be able to go back and replay it and reference that. And
another thing too is shaping fire. I did a wonderful presentation with Shango a year or so ago. There's a 10-minute video clip on his YouTube Shaping Fire site. And then we did the podcast, which was like an hour and a half, where we really chopped it up. And so if you want a refresher, that's a great place or a great resource to go back and check out.
Awesome. There's another question just about basically what are the ideal pots to grow in. I mean, I think you kind of answered that already, Leighton, but I don't know if you want to say anything else about pots.
I like raised beds more than I like pots. I just think that you have more spaces for diversity. I'm a big fan of polyculture. Joshua Steensland's so excited to have him on. I mean, check out his IG page of his indoor grow. I mean, it's a jungle. And his approach to cover cropping was like, I threw a bunch of stuff in there and saw what worked. And I think that is the correct approach. I mean, I'm a big proponent of carrots and potatoes for a root crop, and I'm a big fan of these big leafy greens to help create a microclimate on the surface of the pot. So you really can't do that kind of diversity in a regular pot. So in my mind, the bigger the pot, the better. Get a 200-gallon pot and put a plant in each quarter. That way you're going to get a little bit more surface area to get you diversify your green mulch or your cover crop. So yeah, I mean, again, if you're going to go with a fabric pot, make sure that it has that vapor barrier so that you do not lose your moisture out the sides, and or you don't have correct gas exchange. Because remember, the horizons are designed like soil. Soil isn't ever put in a pot in nature. It's flat. It's level. So there is no sides to the soil that is getting exposed. So again, that's why I like bigger sections like these raised beds than I do the little pots, because you're preventing that both temperature swing, gas exchange, hydrophobic potential. So if you're going to go with a fabric pot, make sure it has the vapor barrier. And I hope I answered your question, my friend.
Yeah, I think that was pretty good. Do you amend the soil with diatoms, or do you water them in? And doesn't this kill off good microlife?
Great question. No, you have to water them in. Diatoms are a really cool creature. I highly recommend you go online, go to Google and go to imagery. I mean, they're like snowflakes. They're just so many different types. The ones that I harvest from back east are more tubular. We found them actually in the water column, and then I started having Keith collect me the solids off of his rotary drum screens, and we put those in a stainless steel tank with no light. And I did have him add oxygen or an air stone, but no, there's no light in it. And then when I went back to harvest it, like a few weeks later, I was amazed at the fact that they were breeding, they were splitting, they were dividing in a tank with no light. And that's when I really kind of made me start thinking about what is their energy source. They're obviously not living off of the sun, they're living off something else. And we know they're producing oxygen. So they're a really interesting creature, but we're going to deep dive into that in January, mid-January. And by then we'll have all the kinks run out of the product production system back east, and these will be available on the market. And those you'll be actually be able to have an AMO, aquatic microorganisms that are complete: diatoms, nitrifying bacteria, phosphate solubilizing bacteria, and all these are what's called in vivo. So they're grown in nature, not in vitro. The problem with growing in a lab is you have basically spoiled children. They've had the perfect environment, perfect foods, no competition, no hassle, and now you take them and throw them into an existing hostile system where everything had to learn to live in this hostile environment. They're a biostimulant. They're not going to last long. So that's why it's really important that when you start talking about using microorganisms like Chris Trump, natural farming, IMO, it's all about IMO. And so the same thing is true, that I'm working with AMO that's being harvested in vivo, in nature, so that they are going to function and survive in your soil system.
All right. Is it possible to plus or minus charge different soil layers to hold nutrients?
Well, those are the micro and macro aggregates. So the beauty of these aggregation processes are that, and we really don't know which one is which, whether the center is negatively charged and the outside is positively charged. My gut feeling is that that's going to be based on what's in that macro aggregate, like what is the content of clay. If there's high silt, then chances are it's going to be more negatively charged, where if it's high organic matter, it's going to be both positive and negative. So that's a complex question that I can't specifically answer, but what I can tell you is if you have aggregation, you have great gas exchange, you have great water infiltration, you have great nutrient storing capacity, and you have a beautiful system that the roots can thrive in and push in all directions and do mine those goodies right out of it. So aggregation is the key to everything.
All right. If you're composting in the Midwest or the Northeast, do you have any recommendations for getting through the winters when temperatures are below zero?
So again, I would be going with a hugel culture system there. So what I used to do when I was in Connecticut was I would build one in spring and one in fall. The reason I build the one in spring is because I didn't want to have to worry about moisture in the summer. And so by building it in spring, by the time summer came, the whole top of the pile was green. It was grown in. So it was protected by its own microclimate. So those leaves protect the sun from drying it out. The miles of roots that were growing off of those cover crops or the little shrubs and trees I planted on it provided that extra aggregation to store moisture. So I didn't have to worry about it drying out. And the opposite is true in the winter. I build it in the fall, I get it going, I get it cover cropped, snow comes in, insulates the whole thing, and then come spring, the snow melts off, all the plants pop back up and take over. So build in spring and fall and obviously don't try to build it in the winter. And if you build in the summer, you're going to have drying out issues. You're not going to be able to get that plants, the cover crops that are so critical to establish themselves.
All right. When you're using wood chips or straw, etc., as a mulch, do you move the mulch to expose bare soil surface when top dressing, or just top dress on top of the mulch?
I would tend to pull the mulch back depending on what it is. A lot of guys will use like a heavy chip to keep the fungus gnats down, which is a great trick. So if you were using chips as a method to prevent inappropriate dehydration of the surface of the soil or to mitigate like a fungus gnat, then I would just gently push it back. Now, if it's just a thin layer of hay, I would just top dress over it, because that hay, as I said, was a great long-term storage for nutrient. And so, again, the hay is going to soak up the top dress if it's liquid. If it's a solid, it's not going to prevent it from getting down there unless it's a super heavy hay. So in that case, if you got, like an inch or two of hay, then yeah, just kind of scratch back the surface. But the hay on the bottom that's coming in contact with soil, don't disturb that, because you're already going to have fungal networks going into that. You're going to have all kinds of protozoa mining it, or bacteria mining it, and of course the protozoa living off the bacteria. So you don't ever want to really disturb your soil if at all possible. So again, I would just carefully peel it back if it's really deep, top dress it, and then cover it back up again.
Hey, that's a great answer, Leighton. Sorry, I couldn't help it. All right, next question. I live in a desert. What can I do to have better finished product growing in desert sand?
Oh, yeah, I was just down in New Mexico, boy. Whew. All right, so you got like 4% humidity in the air. That's insane. You're high altitude, so your UVs are super hot. Before the great human expansion, the prairie grass down there was like 8 feet tall. I mean, there's pictures of guys riding a horse because they had to ride a horse. You couldn't walk through this stuff. You couldn't see where you were going. And so back then the soil was amazingly fertile, and those roots were down, 20 feet. But then we chopped all the prairie grass down and started growing crops, and that caused desertification. So now you're in a situation where, yeah, you've lost all your organic matter, you've lost your clays, all of that's blown away. Like I was talking about, soils are formed through transpiration, transportation. So now you've got to transport that stuff back in. So bottom line is, you're going to do the same thing that I did here in Oxnard. I basically had a sandbox. Literally, that's all it was sand. And so what I did was I harvested or wildcrafted some local chips from a safe place that I knew was not going to have a bunch of toxins or hydrocarbons in them. And so the first thing I did was I busted up the clay or the sand. I loosened it up because it was kind of like crusty on the top. And then I rototilled in a whole bunch of chips. Like I put 3 or 4 inches on top of it, rototilled those in. Then I broad forked them in. So, because you want to try to work them really down into, 12, 18 inches down into that soil profile. And then I came back with a yard of compost. So now I added another couple inches of top dress, and again I rototilled it in first, and then broad forked it in, and then I watered it with a nice compost tea, which in my case was more of a humic acid extract with biology. Let it set up, or sprayed that in, watered in a little bit, cover cropped it, and bam, I had wonderful soil. Now, you're in a desert, so you're probably going to have a different humidity, so it's going to be a little bit harder for you to do that, but that's the way you're going to establish your soil. And then once you get something rooting in there, do never let it get bare, dude. Just whatever you do, you've got to have those cover crops, and you're going to have to cover crop specifically to your area. And again, what those cover crops are doing is they're shielding that soil surface from UVs, they're shielding it from evaporation, and they're creating a microclimate right on the surface of that soil so that you can get that biology to take, and the roots will get down into the deeper parts of the sand. They'll start to be able to mine the little water vapor that's down in there, because it's there. But that's the key to taking a desert back, is just whatever you do, never let it get bare again.
All right, and then there's a question that just says masonry sand ?
Good one. Yep, masonry sand. Masonry sand tends to be a little bit more not as coarse as I want it. I like masonry sand more often than not, depending on which supplier you're working with, will be close to what I'm talking about. I personally like to get sand wildcrafted because you're going to get a bunch of biology with it. So the biology that mines sand is a very specific type of bacteria. Whereas if you're buying the sand from a yard, that's been washed and processed. So you've lost all the life that's on it. So if you're trying to establish, a soil system, now again, if this is scale, that's different. But if this is small scale, no, then I would recommend that you harvest the sand. Ideally, if you're near an ocean where a river meets the ocean, is a great place because you're going to get all kinds of diverse biology. You'll get some calcium carbonate sand as well as some silica sand. If you can't, then go to your river or your stream or your lake and find a natural sand pocket. And again, you're looking for taupe, yellow, slightly orange. Those kind of colors will indicate good mineral content, and stay away from the white sand. Now, if you're trying to do a big commercial grow, dude, get me involved, because there's so much bad shit that can happen. I mean, I've been working for years with different blending companies. I know the ins and outs. I speak their language. I know how to find the sources that I'm looking for, and then have them brought into the blender and then have it blended up. But if you just walk in and say, "Oh, I'm doing a cannabis grow, I need this," first of all, they're going to rape you and charge you 3 times as much. And second of all, you're not going to get the ingredients that I'm trying to recommend to you.
All right. Another question about sand. Sand made from wind is more rounded than water-form sand. Does this make a difference when creating a soil?
Well, that's a great question. I mean, I would say, like, have you ever been on a really windy day down at the beach? And you would see the difference. You would see that white, fluffy stuff that's really soft that I was warning you to stay away from. And then you'd see pockets of this coarser stuff that's got that yellowy, tanny color to it. So again, you're to find these sources of sand, you have to pay attention to nature. And as far as the actual shape of the sand, it's less important than whether it's soft and fluffy or whether it's coarse and a little bit more jagged. But yeah, I would tend to think that with wind, you're going to be knocking the corners off and rounding it. And again, with a softer sand, now you're getting this tiny little sphere that's going to plug up those pores, which we're trying to avoid. So you're really looking for that coarse sand that isn't as mobile in the wind that the light, fluffy stuff is. Dude, you're muted. There
My bad. Go. Okay.
Yep.
So, question was, somebody had asked, can you put a millimeter size on that sand particle size?
Okay, so I think what you're saying is a micro mesh. Micro mesh micron scales. Those are a unit of measurement that soil scientists use to define particulate size. So I would say that you're looking at somewhere around 200 micron. So somewhere between 150 and 250 micron would probably be appropriate. And if you Google micro mesh to micron scale, that would give you that calculation back to what you will purchase for screens. But best way to do it is to learn about sands is go to a masonry yard and go feel them. Just pick them up and run them between your fingers, and you'll tend to see where I'm trying to go with it. I don't want a super coarse sand, but I don't want a super fine sand. Somewhere in the middle. And again, look for those colors. Those colors will indicate, they will steer you in the right direction.
All right, and I'm just trying to hit off all the sand questions here. Someone asked, should I wildcraft my sand from the beach if I can?
Again, where I would go is where the rivers meet the ocean, because you're going to get both the transported sand, the silica sand, as well as the calcium carbonate sand. And again, I'm all about diversity. The more diverse you can get, the better you are. And the other side of that coin is that sand is going to be biologically active. You're already going to have the specific bacteria colonized on that sand that is mining it. And how better to get, that kind of benefit into your soil system is already having the specific type of bacteria that can mine it present on it.
All right. How many milliliters of humic and fulvic acid per liter or per gallon should I use for soil applications? So
that's a difficult question because it really depends on what you're trying to accomplish. If you're sand and you're trying to get that layer to happen, you're going to use a lot more heavily concentrated version. Again, I was using 4 to 5 to 1 water to humic acid, but my humic acid, you got to understand, is like super dark chocolate milk. I mean, it's not like what you're going to get when you purchase it. And if you're going to purchase something, again, go with BioAg, and then I would read the label as to what makes sense. If you're just doing a general drench, you don't need a lot of it. And specifically with fulvic acid, the dilution ratio is crazy. It's 1 to 100. Anything more than that, you're wasting material, or you're just donating it to the soil system. But remember, the fulvic acid molecule is so small that it will wash right down through the soil profile. It's not biologically active, so it's not going to stick. So again, with a humic acid, I would read the label on BioAg's products as to what it is. And again, it's like you're going to use 1 dilution for soil and 1 dilution for a foliar. So again, it would be read the directions. But if you're trying to fix sand or turn sand into soil, very concentrated. And again, I would just experiment. I would try, a little patch and see what happened. Big proponent of trying side by sides and trialing and experimenting. That really helps you get through the humps quickly.
All right, so we're gonna have to wrap up shortly here so we can get to the next session. So just last couple questions.
Sure.
Someone asked, are there pre-made super soils comparable to what we're talking about today for the backyard grower?
Yes, there are a number of super soil companies out there. Soilscape Solutions, Build a Soil in Colorado. Soilscapes is out here on the West Coast. And I would go with someone very experienced. I would not go with the mom and pop that hasn't had a tremendous amount of time to learn their lessons. And by that, I mean not make mistakes, but learn your lessons. One of the biggest problems with someone who doesn't have a lot of experience in blending these things, chances of them blending them inappropriately would be a lot. So just know your vendor, know your supplier, ask for references, talk to those references. How did the soil work? How did it perform? Did it leach out a bunch of fines out the bottom? Did my plants ever hit any kind of deficiency? Or did I ever get into nutrient lock using it? So just do your homework on that.
All right. And then we had a few questions, at least, about using pumice. Is pumice an appropriate choice for an alluvial layer, or just what would you use pumice for? Would you use pumice?
I would use pumice for an aeration. So similar to rice hulls. It's got some water storage capacity. It has some irregular shapes so that you can create pockets for the biology to set up home or set up condominiums. So in that regard, I'd use it there. I would not use it in my E-Horizon. What you really want for an E-Horizon is diversity. So you're looking for all different color rocks. And you don't want round rocks because the round rocks are difficult for the bacteria to set up their biofilm, and they're basically polished smooth. So it takes a long time for that biology to actually build a niche to protect itself. So what I recommend people do is you go to the river, you find all these round rocks that are all different colors, and smash them up. Get good and stone and beat the hell out of them with a sledgehammer and make as many jagged corners as you can, because the more jagged they are, the more surface area that the biology has a chance to set up on and mine. And again, the different colors represent different minerals in the stone itself.
All right. And just lastly, somebody had asked about the Johnson-Su bioreactor. Are you very familiar with that, Leighton? Do you have any comments on that?
Oh, man. What's so funny is I used the term bioreactor for years, and I never heard anybody question it, right? And then literally like 4 times in the last few months, I've said that, and they're like, oh, Johnson-Su? And I'm like, who the hell's Johnson-Su? So I finally did the homework to figure out who this was. And it was a couple that had put together a composting method that they let sit for a year. And that was what they called the Johnson-Su bioreactor. This is different. but it's basically like, use your head, like think about it as like this little, nuclear reactor. So what's happening in that sphere, about a third of the way down in this pile, is where all the magic is happening. So, I didn't mean to steal their term, but I just used it because in my mind, it made sense that sphere was a reactor of some kind. That's where all that magic was happening. So I'm now familiar with who they are, but not comparing them, or it's not the exact same system.
Yeah. All right. Well, we've got to wrap it up now and get over to Elaine's presentation starting in about 5 minutes. So thanks, everyone. Thank you, Leighton. That was awesome.
Pleasure. My pleasure. Looking forward to the next one. We're really going to go deep, guys, really deep. All right. Peace out.
Thanks, everyone. We'll see you there.